Hey guys, welcome to question FM 399 of the Further Maths 4 to 5 study guide. So this question reads, Maya makes homemade dog treats and sells them online. Let X be the number of beef treats Maya makes each week. Let Y be the number of chicken treats Maya makes each week. The inequalities below represent the constraints on the number of each treat that can be made each week. We've got constraints 1, 2, 3, and 4. Question A wants us to interpret constraint 3 in terms of the number of beef treats and the number of chicken treats produced each week. So we've got this y is less than or equal to 3x, y being representative of the chicken treats and x being representative of the beef. So in order to equalize these two, and I've mentioned this technique in an earlier video, but I would equalize them by saying 3 and 1. So we've got an equality here, we've got 3 on one side and 3 times 1, so 3 on the other side. What we can see here is that if we have 3 chicken treats, then that would be equal to 1 beef treat in this scenario. So if we were to have 4 chicken treats compared to 1 beef treat, that wouldn't be okay, because that wouldn't satisfy this less than part of the equation. So this could be less than or equal to. So 3 chicken treats to 1 beef treat would be okay, but 4 chicken treats to 1 beef treat would not be okay. Alternatively, 3 compared to 2, so this would be 3 is less than or equal to 6. That would be okay, so having 2 beef treats and 3 chicken treats would be okay, but we couldn't have 4 chicken treats and 1 beef treat. So we might write something along the lines of, so we can't have more than 3 times the number of beef treats being made in chicken. We're then given another little graph, so we're told that there is another constraint. Constraint 5 on the number of each treat that can be made each week. Constraint 5 is bounded by line A, shown by the graph below, and then you've been given a graph that looks kind of like this one. I've just left the important information there though. The shaded region of the graph contains the points that satisfy constraints 1 to 5. B wants us to write down the inequality that represents constraint number 5. So we're looking at this line here. We can see that this line goes from a y value of 100 to an x value of 100. So if you're getting pretty familiar with your graphing by now, you might know that that line is represented by x plus y equals 100. However, we're not going to leave it like that because we've been told that this is an inequality or a constraint. So it's constraining it in some way. So we're going to have to use either a less than or a greater than symbol with either an equal to, less than or equal to, or greater than or equal to. Now the reason we know that is because this line is filled in. It's not a dotted line, so it's not just a less than or just a greater than. So we know it's going to have that or equal to component. Now this is actually x plus y is less than or equal to, and the way that we know that is because this shaded region is on the left and down side of the line, which are the two negative directions for both x and y. So x and y must be less than this 100 value rather than greater than, which would put it over on this side. We're then given actually a fair bit more information. So what we're told is that the profit that Maya makes from selling dog treats is given by P equals 3.7x plus 4.5y. Find the maximum profit that Maya can make from the sale of dog treats each week. So there's actually a little bit to this question, and I might sort of separate it a little bit on each side. But basically, we're going to find these 2 points here, because it's highly likely that one of these 2 points is going to contain our maximum profit that Maya can make, because these are sort of the two, what would you call it, the ends of our feasible region. So we wouldn't pick this 0, 0 because obviously she's going to make 0 profit on that. Our only other 2 points that are left as sort of extremes are these two here. Now, the way that we're going to do that is by figuring out these points of intersection by transforming our equations and using any method you guys choose. So you could use your calculator, you could do it by hand to basically find out what these coordinates are, what these points of intersection are. So we're going to start by taking, let's say, this point here. So this point is using the two lines, it's using this x plus y equals 100 line. So we're going to rearrange that a little bit and say that y is equal to negative x plus 100 is one of our lines. And this line here is going to be our y equals 3x line. So if we put this into an equation where we make y equals y, we'd have 3x equals negative x plus 100. And solving this down using your calculator or by hand, you're going to get an x value of 25, which if you substitute it back into either of these equations is going to give you a y value of 75. The other point that we're going to look at is this guy here. Once again, still using that x plus y equals 100, rearranging it to y equals negative x plus 100. And then underneath it, where we've got 4y is greater than or equal to x. So converting that, we're going to have y equals x over 4. So making y equal to y, once again, we've got x over 4 equals negative x plus 100. Solving this down for x should give us x equals 80, which means that y equals 20. Putting these two ordinates or these coordinates into our profit equation, we can get 3.7, or I should say P equals 3.7 times 25 plus 4.5 times 75. If we were to put that into our profit equation, we should get an answer of $430. And if we look at this side over here, using that same profit equation, we get 3.7 times 80 plus 4.5 times 20, and that's going to give us 386, which means that the answer to this question is the $430 because that's more profit, obviously, than our 386. All right, now part D. This one's actually fairly tricky. So Maya wants to change the selling price of her beef and chicken dog treats in order to increase her maximum profit to $447. All of the constraints on the numbers of beef and chicken treats that can be made each week remain the same. The profit Q that is made from the sale of dog treats is now given by Q equals IX plus JY. The profit made on the beef treats is I dollars per treat, and the profit made on the chicken treats is J dollars per treat. The maximum profit of $447 is made by selling, so I might even just jot some of these down. So the maximum profit is $447 by selling, 41 beef treats. So X equals 41 and Y equals 59 chicken treats. What are the values of I and J? Write your answer correct to 2 decimal places. So there's a fair bit going on here. This is a tricky question that a lot of students struggle with. So if you did struggle with this one, don't feel too bad. I'll take my time in explaining it as well. Now, the first thing you're going to maybe notice is that this coordinate here, we've been told, first of all, that all the constraints remain the same, which means that this feasible region graph is still valid. This point here, where x is equal to 41 and y is equal to 59, occurs on this line, What you will notice though is that it's not either of these points, because one of our points, if I remember correctly, was 80, 20, and the other one was 25, 75. So this point, which is 41.59, is actually somewhere on this line, okay? And that line is the line of x plus y equals 100. So somewhere along here. Now that x plus y equals 100, the fact that it's on this line is actually really important to what happens next. So what's important is that it's on this line and it's neither of these end points. Because what that tells us is that the equation for this line here, this maximum profit line, that has to occur, it has to have the same gradient as the line of x plus y equals 100. So if you're not really sure why, go back and have a look again at your sliding technique rules. But basically it means that this maximum profit line must come up and meet like this, because if it was even slightly tilted this way, then our maximum profit would occur up here as we slid up there. And if our maximum profit was even slightly curved this way, I shouldn't say curved, but if we had a steeper negative gradient, we would go all the way out to this point here. So the fact that our maximum profit point occurs along this line tells us that the gradient must be the same this way, which tells us that our gradient is equal to -1, because the gradient of x plus y equals 100 is -1. And if the gradient is equal to -1, then I must be equal to j. Okay? That's a really important piece right there, because that pretty much holds together the rest of the question. So once you've got these two things figured out, the rest comes fairly easily from there. Because what we're going to do next is we're going to say, well, Q, our maximum profit is when we have 41 beef treats. Now don't get your I and X confused here, because X represents the number of beef treats and I represents the profit made on those beef treats, which we don't know yet. So that 41 replaces the X, not the I, plus 59J. We've been told that I can be equal to J, so technically this could be 41I plus 59I. That should make a difference, and that equals 100I. Substituting our maximum profit of 447, we get 447 equals 100I, which means that I is equal to 4.47, which is also equal to J. And those are our values of I and J. Guys, if you have any questions about any of these questions, please leave them in the comment section below. Otherwise, I'll see you in our next video.